Hello class, in this video we will talk about the ambiguous case of the sine law, and this only works, or this will only come out if again the triangle is called SSA. It means two sides and the non-included angle are the one being given. And yeah, this is our setup. The triangle may look different. It has many forms, but let's just stick to this one. What matters here, class, is you must really understand. You have an understanding and you really know how to identify if the triangle is SSA. Now, two sides and the non-included angle. So that's just it. So A here is our given angle. A here, let's just name this A, opposite side of given angle. So again, the names here, the letters varies. So the letters are not important. What matters here is you know that this is the opposite, this is the given angle, and this is the adjacent. So the letters will vary. Make sure that you just don't confuse the opposite and adjacent and the height and the given angle. That's just it. And the height here plays an important role, and it can only be computed by multiplying the adjacent with the sine of the given angle. It's not a complicated formula. So let's move forward. So again, the form depends on what is given. This one is not really generic, but let's just stick to this form. So if the opposite, again, this is opposite of the given angle, is greater or equal to the adjacent side, then automatic one triangle exists, and we can use the sine law to compute for the other missing parts. That would be the other angles and sides that are not yet given. Now, this is the ambiguous case. The ambiguous case exists if the opposite is less than the adjacent. Now, for this automatic, we need to compute for the height, which is very easy to compute, especially with our cycle, we can do that. And if we find out that the opposite is less than the height, automatic, there's no triangle, we don't need to solve. We just conclude that there's no triangle, but you must show your computation for the height and the comparison of the opposite and the height as your support of your claim that there is really no triangle. Now, if it happens the other way around, the opposite is greater or equal to the height, automatic, there is one or two triangles. So how do you know one or two? Well, simple. If it is equal to the height, that's one triangle. But if it is greater than the height, automatic, we have two triangles, period. That's just it. It's very simple. It just needs more practice. So this is a diagram that might help you. So let's move forward. So here we have the diagram to help us or to guide us in our solution. So we need to solve the triangle. Again, solving triangle, class, only means we need to find the other missing parts. So we already have one angle here. We need to find the other two angles. We have two sides. We need to find the third side. That's just it. Now, to do this, again, we need first to test if the triangle is ambiguous or not or whatever. So we need to compare to find out the given. So we have an SSA. So this is most likely ambiguous side-side angle. Second, we see that the opposite is less than the adjacent. So right here, it falls in the ambiguous case. The opposite is less than the adjacent. So we are forced to compute for H. This is an ambiguous case. That means there are three possibilities: 0, 1, or 2 triangles depending on our height. Yeah. So without further ado, let's compute for the height. So it's just adjacent times the sine of 27. So you can use your cycle to follow this video, and we can get an approximate of 12.7. So upon comparison, we see that the opposite side is greater than the height. 18 is greater than 12.7. So what does this imply? If you remember earlier, it means that we have two triangles. How do you know if 2? It's greater. If it's equal to the height, that's 1. But if it's less than the height, then no triangle. We don't need to compute further. Okay, so we have two triangles. So Let us do this step by step. Let us first solve for the first triangle. So right here, the first part that we can solve is the angle opposite the adjacent. That is like SOP, standard operating procedure. We cannot solve for the other parts. We are really going to solve first the opposite of the adjacent. So that would be, let's just say this is A1. This is, why do we have this 1? Because again, there is a second triangle. And B here, A, and the other B. Why no subscript? Because these three are given. These are fixed. So there is no change for these three. But for the other three, there will be changes for the second triangle. All right, so again, we just use the sine law. So sine of B over B equals sine of A1 over A. So we will just follow through. We will do the cross multiplication. This one cross multiply here. And eventually we get an approximate of 0.706. So the more decimals, the more accurate is your value. And we will apply the inverse sine so that this becomes A1, and right here inverse sine. So we will just use cycle, and we can find that the approximate of that would be 45 degrees. So right here, A1 here, angle A1 is 45 degrees. Now, we already have two angles. We can now simply compute for the third angle, which is angle C1, by just subtracting 27 and 45 from 180. So we will get 108 less. Simple, very simple. Now we have complete angles, C1 here being 108 and A1 being 45 degrees. Now let's proceed with side C1. We already have side A and B, but we are lacking side C1, so we will again use the sine law. Maybe we can use this proportion of the sine law, B and C1s. So we will just substitute. We will cross multiply. So C1 cross multiplied here, and sine of 27 here and 18 there. So approximately we get 37.7. So this is now our first triangle. We have already solved the first triangle ABC, complete three sides, so complete three angles. Now, you might be wondering, where is the second triangle? How do we do that? So I need you to carefully listen to this part of this video. So first, we need to uh, rotate this one. We are going to rotate the opposite side. So rotating that here, imagine you rotate, so somewhat like this. So it will end up somewhere here. So that is still the same opposite side. That is still 18. Rotating there. And next is, so this is now the new angle here, right here. It's now the new angle C. Let's just name it C2. And this is now the new opposite side of C2. So that's small c2 right here, the shorter one. And this is now the new angle A. And let's just call it A2. Now, what? So let's just simplify things. That's the second triangle, class. Okay, that's the second triangle. Let us simplify to avoid confusion. This is the figure for the second triangle. Now, how do you compute this? We don't need the sine law. We don't need the sine law for the opposite of the adjacent. The second uh, angle A2, we will just subtract A1 from 180 degrees. So remember, to get the second A2, the opposite of the adjacent, the second A2, just subtract the first A1 from 180, because these two are actually supplementary. Alright, so we have 135. So this is 135. No need for sine law. Just apply supplementary, because A1 here, the previous A and the new A are supplementary. So just subtract it from 180 degrees. And that's it. We have now 135. We can now solve for the second C. Again, we just subtract the two 27, 135 from 180 degrees, and we get 18 degrees. So that means that the second triangle exists since this is solved. Sometimes when you solve the third, when you solve the third and you get like zero or negative, yeah, when you solve for the third one and you get zero or negative, that means there is no second triangle. We only have one triangle. Okay, so let's solve for the small c2, the side here. So we will use sine law, substitute, derive, and we get an approximate of 12.2. And here you go. This is now class our second solved triangle ABC. And that's it. As simple as that. We just need to practice more to familiarize or memorize the the idea of the ambiguous case. So again, if you go back to the first triangle, this is the ambiguous two overlapping triangles ABC. That is somewhat confusing, I guess. So if we um, separate these two, so these are the two ambiguous triangles ABC. So that would be all for this example, and thank you so much for watching. Enjoy the rest of the day.